All right, this is part 2. This is solving systems of equations with either substitution or elimination. All right, both of these are valid ways to solve systems. You use substitution when you see in one of the equations that there's a lone variable there that you can solve for, so you can substitute that binomial in for that variable in the other equation, and I'll show you what that means. The next is elimination. Elimination is just adding or subtracting equations together. If they have the same coefficients, you can eliminate them by subtracting, or if they have opposite coefficients like 2y and negative 2y, you can add those two things together. Now you've eliminated the y, so you can solve for x. You choose which one you like. What I'm going to do is I'm going to move this down, run to one of these equations. I'm going to show you both ways how to do it, and I'm going to show you how you might want to choose. And instead of using this nonsense, I'm going to show you how you're going to make this work. What I look for most of all in my systems, the first thing I look for opposites. I put my googly eyes on, right? There are my googly eyes. And my big nose. I guess my nose should be bigger, right? Let's make that bigger. There you go. That's a soapal nose right there. I look for opposites or lone variables. I wish I could write. Anyway, so in these first two, I have lone variables. I don't have any opposites. And when I mean opposites, I'm looking for a y and a negative y. This is negative 3. And I can use elimination here, and I'll show you how. With this one, I'll use elimination on this. But both of these, personally, Sokol would use substitution because I see lone variables in each of them. I don't want to have to do a lot of extra work, but I will if I have to. If I see a lone variable, I just solve for that lone variable. And then I take that piece that's on the other side and I substitute it for that y. For instance, y, because this is the lone variable, I'll just rewrite it and make it y equals negative 3x plus 7. Now I have something I can plug in for y in the second equation and solve for x. Now I'll actually have a number that satisfies both equations for x. And I'm sure you've done this last year, but I'm reminding you. So step 1, substitution. Step 1, solve for a lone variable. And I've just done that. And then step 2, substitute. Substitute that binomial in here for y. Then you can distribute and do the rest of the math and solve for x. Because what this says is that y, once I got rid of this, y is now equal to negative 3x plus 7. And so down here, this y is also going to be negative 3x plus 7. And then I will solve it for x. So I'm going to rewrite it over here. I'm going to say 4x plus 2 times what we found, negative 3x plus 7, equals 16. I'm sorry, I'm running out of space. I hope you can see that. It looks like you can. When I start to solve, I'll just move this over just a tad. How about that? We still have 4x. We still have an addition sign, but let's distribute. 2 times negative 3x is negative 6x. And then 2 times positive 7 is positive 14. And this is all equal to 16. Now we can solve for x. 4x plus negative 6x is negative 2x plus 14 equals 16. We subtract 14 from both sides, right? And we have negative 2x equals 2, or x equals negative 1. Here we go. We take that x equals negative 1, and then we can put that back into one of these two original equations and solve for y. So far we have x equals negative 1. And now I'm going to put it in here, into this equation here, and solve for y. You can put it in either one. But I like this because it has a lone y, and it's so much easier to do. So 3 times negative 1, that's what I found for x, plus y equals 7. Okay, 3 times negative 1 is negative 3, plus y equals 7. Add 3 to both sides. Then y is equal to 10. Okay, so now we have x equaling negative 1 and y equals 10. Those are my two solutions. If I want to, I can put them back in here, and I'm finished, right? Good. That's really all there is to it. You can rewatch this over and over and over again. I'm going to be going through it in class. If you have any questions, of course, you can always ask. All right, that was substitution. Let's look for opposites. And then we'll do elimination. And I'm going to do my elimination up here because I have lots of space up here. But first, I want to find something I'm going to be able to add or subtract. And when I have a lone variable, I can usually multiply by some factor to get there, right? And if I want to eliminate, it means when I add these two together or subtract them, I can get rid of a variable. And I can get rid of this y if I go ahead and say this whole thing, multiply it all by 3, I can then add these two things together and eliminate my y. So, I'm going to rewrite this up here. 3 times 2x plus y equals 5 times 3, right? And I'm going to do that math first before I put the 3x minus 3y equals 3 underneath it. I'm going to say this is equal to 6x plus 3y equals 15. That's me doing all the math, doing the distribution, and multiplying that by 3. Good? You should know how to do this. We've done this a number of times. Here we go. Now, I'm going to write underneath it 3x minus 3y equals 3. That's a lot of, nuts and bolts. I found an easier way. I'll show you what that easier way is momentarily, and then you'll be able to see. But I'm going to go ahead and do my elimination. I'm going to add these two together. 6x plus 3x is 9x. Positive 3 plus negative 3 is 0. So I have no y's left, and I add these together and I get 18. 9x equals 18. Obviously, x must equal 2. Good? Once I have my x equals 2, I can plug it into any of these original equations and solve. I'm going to solve for this guy. Why? Because there's a single y right there. I love lone variables. They make our lives so much easier. We don't have to do all that work. 4 plus y equals 5. Subtract 4 from both sides. Y equals 1. 5 minus 4 is 1, right? So we have our two solutions. X is 2, y is 1. If we put them in here, we would get the same thing out. Obviously. Sound good? Here's what I noticed that I should have noticed that would have made our lives a little bit easier. I could have divided this whole thing by 3 and then eliminated. Sorry. But you can do that. Because I would have made this 1, 1, and 1. I could have eliminated and had 3x equals 6. I still come up with x equals 2. Either way, it wasn't that much more work. Those are the two ways to do it. Thank you for your time. Here we go. We're on our way to big math.